This is lesson 2.3. The learning target for this lesson is I can make logical arguments using deductive reasoning. So please make sure that you write down the learning target, and also please make sure that you are using pencil to do your notes. We have a few vocabulary. The very first vocabulary is what this entire lesson is about, which is deductive reasoning. Deductive reasoning uses facts, definitions, laws of logic to form a logical argument. So deductive reasoning is much different than inductive reasoning, which we were learning about a couple of lessons ago. Inductive reasoning is where you're using patterns and observations to make decisions, but deductive reasoning is using facts, definitions, and laws of logic. One of those laws of logic is the law of detachment. The law of detachment says if the hypothesis of a true conditional statement is true, so if the whole conditional statement is true and the hypothesis is true, then that means the conclusion is also true. So with the law of detachment, you're going to get a general statement, and we're going to practice this in just a moment. The general statement is the true conditional statement. And then they're going to give you a specific situation where you can apply the information in the general statement, which has already been determined to be true. So it might be a good idea right now to go down and look at example number 1, where we're going to use the law of detachment. So in example number 1, we see a general statement. The general statement is if two angles have the same measure, then they are congruent. So we already know that this is the hypothesis, this is the conclusion, and both of those things are true. If two angles have the same measure, then they are congruent. So this is a general statement. The first thing that you get here is a general statement, and now we're going to be looking at a more specific situation, which is this information right here. So this is our specific scenario, and we have to use our general statement to make a decision or conclusion about this statement. The measure of angle A equals the measure of angle B. Well, from our general statement, it says if two angles have the same measure, then they are congruent. And our specific scenario is saying that angle A equals angle B. So since they have the same measure, we can conclude that they are congruent. So we'll just say that angles A and B are congruent. Okay, so the measure of an angle, let's say measure of angle A is 50 and the measure of angle B is 50, then that means they are congruent. They have the same exact measure. Now let's go back and take a look at the law of syllogism. The law of syllogism is different than the law of detachment because it does not give you a general statement. It just gives you two conditional statements. The first one, if you take a look at it right here, if the statement, if hypothesis P, then conclusion Q is true, and a second statement, so we're having two statements. And then it says if hypothesis Q, notice that the Q came from the conclusion from the first statement, but now Q is the hypothesis of the second statement, then conclusion R is also true. Okay, so basically you can rewrite the two statements into one. Rewrite two statements into one statement. And we're going to practice that in just a moment, but notice what we have. Instead of having hypothesis P conclusion Q and a separate statement hypothesis Q conclusion R, we just have if hypothesis P, then conclusion R. The hypothesis P came from the first statement, the conclusion R came from the second statement, and basically we can just get rid of these things and condense everything down to that more simple statement. In example 2, we are asked to use the law of syllogism, and it states here, if possible, use the law of syllogism to write the conditional statement that follows from the pair of true statements. So here we have two conditional statements. If the electric power is off, then the refrigerator does not run. So let's just label this with P and this with Q. So our hypothesis is P, our conclusion is Q. If the refrigerator does not run, then the food will spoil. Well, we just saw this statement, the refrigerator does not run. That was Q. All right, and now we have a new conclusion over here, then the food will spoil. That is going to be R. Now remember, I mentioned in the example that, well, not the example, but the definition. If we have the same conclusion here as we do the hypothesis in the second statement, we can just get rid of those things. If there's a repeated piece of information, as long as the two statements are true, we can get rid of that, and we can rewrite hypothesis Q, then conclusion R. Okay, so we're going to rewrite the statement completely. If the electric power is off, then the food will spoil. So notice we had two statements to begin with, but because each of those statements had a repeated portion, we were able to get rid of those pieces that were repeated and just leave in what was necessary for us to state. All right, part B here, for example 2, gives us some math information. It says in statement number 1, if 2x is greater than 10, then 2x is greater than 7. And in the next statement, if x is greater than 5, then 2x is greater than 10. Well, as we did before, let's label our parts. It looks like we have a hypothesis and a conclusion, a hypothesis and a conclusion. Well, in this statement here, a conclusion says 2x is greater than 10, but a hypothesis here says 2x is greater than 10. So remember, if we have a repeated hypothesis and conclusion, we can get rid of those, and then we can just rewrite the information so that we condense it down. Basically, we're rewriting this hypothesis first, so if x is greater than 5, and the conclusion that we're going to write and keep in is going to be then 2x is greater than 7. So the law of syllogism allows us to get rid of the parts that have been repeated and condense down into one more simple statement. Before we go on to the second page, or the back side of this first page, I just want to remind you that you have these on your own practice problems to do for the law of detachment. And then when you go to the back side, you're going to see a couple of practice problems for the law of syllogism. So on the back here we have a couple of practice problems for the law of syllogism. Please make sure you try those. If something gives you a problem or if you have a question, you can ask about that in class. The last thing I'd like to do is take a look at a couple of situations where we have to use deductive reasoning because we have a fact or we have a definition of some sort and we need to make a determination if the conclusion that is given to us is valid or not valid based on the facts that we know. So the first fact says if the sum of the measures of two angles is 180, then the angles are supplementary. Now that is a fact because if two angles add up to 180, we do call those angles supplementary. And in this statement we're given that the measure of angle A plus the measure of angle B is 180, and then the conclusion someone has made is that angles A and B are supplementary. And is that a valid statement? Absolutely. We know that the conclusion is true because, and we have to state why, the definition of supplementary says if two angles equal 180, then they are supplementary. So the conclusion, angles A and B are supplementary, is definitely valid. And using the deductive reasoning, that's basically how we came up with the idea that it is valid. Deductive reasoning is using facts, definition, and laws of logic to make conclusions. So if we look at number 2 here, we're given that the measure of angle ABC is 95 and the measure of angle DEF is 90. So if that's the information we're given, then we need to determine if the conclusion is valid. Is it valid that the two angles ABC and DEF are supplementary? Well, if we look at the measures of these two angles, 95 and 90, that's going to be more than 180. So our statement of our conclusion statement is not valid, and we have to explain why. 95 plus 90 is 185, and this is not 180. So these angles are not supplementary, because we know that as by definition supplementary angles equal 180 degrees. Okay, let's take a look at number 4. Number 4 gives us a fact. The fact that we are given is if a point is the midpoint of a segment, then it divides the segment into two congruent parts. Well, this is the definition of midpoint. And we know that from our earlier work in geometry that a midpoint is halfway between two endpoints. So let's take a look at the information we're given. R is the midpoint of QS. So if we have a segment, QS, and R is the midpoint, meaning that it's halfway between Q and S, is it valid that the conclusion could be segment QR is congruent to segment RS? Well, that's absolutely true, because the definition of midpoint says that the segment would be bisected by that midpoint. So the definition of midpoint is why that conclusion is valid. And if we look at the final example here, example number 5, we're still referring back up here to this definition of midpoint. It says that segment AB is congruent to BC. So is it valid for us to assume then that point B divides AC into two congruent segments? Well, I've seen segments like this before where AB is its own segment, because all we're saying is that segment AB is congruent to BC. We're not saying that the two of them are on the same exact line. We're not saying that points A, B, and C are collinear. It could be that segment AB is separate from segment BC, so we cannot assume that point B lies on segment AC when we say it this way. So we would have to say no, A, B, and C, points A, B, and C, may not be collinear. We don't know if they are, so we can't assume that they are. And again, remember this little demonstration here that I gave you, AB might be a completely separate segment from segment BC. So just as to wrap up, deductive reasoning is using facts of geometry or math, definitions, and laws of logic to make conclusions. Please make sure you do your on your own problems, and then again, you can ask questions in class if something did not make sense.